Okay, here's question number 11 from section 3. Keep them coming. Thank you, guys. So this one is not an equilibrium that we've been talking about lately. So notice the arrow right here. So it is the burning of ethanol. So the first question is oxygen oxidized or reduced? So remember, when you have an element all by itself, here the oxidation number is 0. And then in a compound, in most compounds, oxygen is a -2. So because it went from a 0 to a -2, it was reduced, and that means it gained electrons. B is it was burned, and then they gave you the volume, the temperature, and the pressure, and they asked you how many moles of carbon dioxide. So you just, again, use PV equals nRT, and that's the answer I got. C is how much ethanol was burned in order to produce this much carbon dioxide. So using stoichiometry, very detailed, it's been a while, right? I'm starting with the 0.767 moles of carbon dioxide, looking at the coefficients in the balanced equation, getting to the moles of ethanol, going from the moles of ethanol to the grams of ethanol from the gram formula mass, and then because they gave me density, I'm going to use that density in the equation. So just be careful, because the density has 2 sig figs, so our final answer would have 2 sig figs. So that's how many milliliters of ethanol were combusted in order to produce the answer to B, which is 0.767 moles of carbon dioxide. Now D is how much heat was released. So if you look back on the original equation, they said based on this reaction, so based on 1 mole of ethanol burning, this is how much is produced. So what I did was for some reason, I based it on the carbon dioxide, 2 moles of carbon dioxide. So I said, all right, in the equation that they gave us, that's how much heat was released when 2 moles of carbon dioxide were produced. So how much heat would be released when that much carbon dioxide is produced? So you could either write negative 487 kilojoules, or you could just say 487 kilojoules were released. So when you say the word release, the implication is that it is a negative. Okay, E, this is a pretty involved question. They're saying this is burned in a room that had a certain mass of gas. So they're asking you for the final temperature, and they're giving you mass and specific heat. So the equation that we're going to be using is Q equals mc delta T. Couple of tricks in this one, in that when we solve for D, our units are kilojoules, right? So we need to convert that to joules, which is our Q. And the reason we need to do that is because our specific heat capacity was in joules that they gave us. So this is the mass of the air they gave us, that is the specific heat, and then I solve for change in temperature. Now because it's exothermic, it's releasing heat, they gave us the initial temperature of the air, so I added that change in temperature to end up with 30.4 degrees C. And just a little bit with sig figs. Remember, when you're adding, you round to the least amount of decimal places. All right, F was comparing the boiling points, and they asked you between to compare ethanol and dimethyl ether. Dimethyl ether has a much lower boiling point than ethanol, and the reason that is I wrote ethanol has an OH bond, so therefore there's going to be stronger hydrogen bonding attractions between ethanol molecules compared to dimethyl ether's dipole-dipole forces. So dimethyl ether is not a nonpolar molecule, though it looks very nonpolar. It's a polar molecule because it has a bent shape, where it has those lone pairs of electrons on the oxygen. And then lastly, G was how would you increase the production of ethanol? And you can't remove anything. You can't remove any, sorry, I'm just reading it. Yeah, you can't remove any chemical species. So what I was looking at is I was looking at the heat. There may be other ways. I guess probably with pressure you could do something, right? So if you increase the pressure, that would also be an answer. Because you have 2 moles of gas on this side and 1 mole of gas on that side. But what I focused on was the exothermic nature of this reaction. So if I rewrote the reaction and I just put it this way, right, because if it's exothermic, the heat term is written on the product side. If I took heat away as a stress, then my system is going to shift to the right to produce more ethanol. So heat, even though it's not directly temperature, in this case, you can say if you lower the temperature, you're going to lower the heat, which is going to shift the system to the right and make more products.